Hi everyone, it's Miss Berry. Today we are going to go over section 2.1. I'm calling chapter 2 or unit 2 problem solving with triangle congruence. We're going to be just focusing on triangles in this unit. In the last unit, we looked at circles, we looked at different polygons, and now we're just really honing in on triangles. And we're also going to be learning more about proofs, and you might find that this chapter or this unit to be difficult. And I want you to know that it's okay if you're finding this chapter or this unit to be tough. It's meant to be tough, and it's meant to challenge you. And I want to encourage you to, sit with your struggle here. And I know that the more that you practice, the better you're going to get at this. All right, so let's get started. Section 2.1 is called Triangle Congruence Theorems, and this section is really just kind of setting us up for the rest of the unit or the rest of the chapter, and this is kind of giving us a bunch of theorems that you're going to need to use in proofs for the rest of this unit. All right, so you're going to see a lot of theorems today, so I want you to make sure that you are pausing the video, writing these theorems down. Make index cards for them. Use Quizlet. Make a little, stack of index cards or whatever you call them on Quizlet. And do those every day. Go through them once a day. And I promise you that by the time we get to this next test, they're going to be second nature to you. You're going to know exactly what each of them is just by looking at the name. Right? So let's look at, to start with, we're just going to look at just kind of the concept of congruence. All right, so here we have two triangles. You can see that they do look somewhat similar, and one of them kind of looks to be flipped, like a reflection of the other one. And it says, suppose that you were told that triangle ABC is congruent to triangle PQR. All right, so as you can see, that symbol there means triangle. Then we have the name of the triangle, and then this symbol in the middle means is congruent to. Is congruent to. All right, I'm going to write that just really quickly here. So this symbol means is congruent to. All right, now the order that these triangle names are written in is super important. You cannot mix up the letters here on the names of the triangle and still know that they are congruent. Okay, so what I mean to say is I can't say triangle ABC is congruent to triangle PRQ. That's not true. What is true is what they have given me here, which is that triangle ABC is congruent to triangle PQR. All right, so if you know that you struggle with like something like dyslexia, you're going to want to really take your time here and carefully, either draw out the congruent mark, the little tick marks, or highlight them in a certain color. And that's what I'm going to do here. So what I want to show you is that, let me switch to my laser pointer. All right, so ABC corresponds to PQR. All right, so AB corresponds to, all right, so AB, that's the first two letters in the name, so that corresponds to PQ. All right, so AB is congruent to PQ. All right, those two sides are the ones that match up. All right, so if we want to indicate that on our drawing or on our diagram, we're going to put an equal number of tick marks there. So you can see I have one tick mark on AB, I've got one tick mark on PQ. All right, next up, we would say that BC is congruent to, what do you think? BC is congruent to QR. All right, so here's BC. Sorry, I did that in the wrong order. But BC is congruent to QR, so you're going to put the same number of tick marks on those. And then lastly, AC is congruent to, what do you think AC is congruent to? It's the first letter and the last letter, so that's going to be PR. And it's okay to say RP. It is okay to flip the order of the way that you're saying, you know, you could say AC or CA. Okay, either way is fine. So AC is congruent to PR or RP, whichever one you want to say. And then lastly, BC, like we said, is congruent to QR. All right, so I want to encourage you whenever you're working with a proof, if you feel like I'm not even sure where I'm supposed to start, then one way that you can start is look at what you're given. If they tell you that two triangles are congruent, go in and label every piece that is congruent. Go in and label those matching sides, and that might, you know, lead you to, you know, some progress in your proof. All right, so we're going to start off with a question that it may look tough right now, but it is actually, you're going to find that it's very simple, and everything we need to know is actually given right here in this picture to us. It says, if triangle ABC is congruent to triangle DBE, find the value of x. All right, so sorry, C is already highlighted. That wasn't supposed to be highlighted yet, but it's okay. What I want to focus on right now is I want you to understand two things. First of all, they've told us that these two triangles are congruent. All right, so let's look at the triangles. Here's triangle A, B, C. All right, see, these two triangles share an angle, so they both share this angle B. All right, and sorry, I was just thinking of a different way to solve this than I did it. Maybe a little bit easier. So we'll talk about that in just a second. All right, so A, B, C is congruent to D, B, E. Okay, A, B, C is congruent to D, B, E. So if we wanted to, we can go in here and label this. We can say, okay, well, that means that AB is congruent to DB. All right, so AB is congruent to DB. All right, so I did 2 tick marks there. You could do 1, it doesn't matter. All right, and then it says, since ABC is congruent to DBE, that would mean that BC, all right, BC is congruent to what? What do you think BC is congruent to? BC would be congruent to BE. Okay, so let's mark that. I'm going to do, I guess I'll just do 1 tick mark this time. BC is congruent to BE. I tried to make that a little bold so you can see it. All right, and then lastly, AC, let me switch to my laser pointer. AC, what do you think side AC is congruent to? If it's the first letter and the last letter. DE, right? All right, so let's mark that one. I'm going to use a different color. All right, I'm going to do 3 tick marks on this one. So 1, 2, 3. 1, 2, 2, 3. Whoa, that side didn't look so good. Let me try that again. Okay. All right, so now we've got a bunch of information labeled. We can even go in here and label the angles that are congruent. So if you wanted to do that next, you could say, okay, angle A must be congruent to angle D. All right, so angle A, which is right here, would be congruent to angle D. Right? Now, that didn't give us a ton of information because they just told us that A was x plus 6, which is, you know, we're supposed to find x, so that doesn't really help us that much. But let's look at the next one. Angle, so we just did A. I forget that you guys can't see my pointer unless I change it to laser. All right, so A was congruent to D. Of course, B is congruent to B. That's the same letter. All right, so let's mark that. I did one little swoop there on angles A and D, so I'm going to do 2 lines here for B. All right, so that means that these 2 angles are congruent. Let me switch back to that laser. These 2 angles are congruent. That means that since they told us that this angle is 50 degrees, that means that this angle is 50 degrees. All right, so this angle is also 50 degrees. So if you want to label that, you can. And I know this diagram is just getting messier and messier, but in a second we're going to cover some of it up and it's going to look so much nicer. All right, and then lastly, angle C. What do you think angle C is congruent to? Angle C is congruent to angle E. All right, so let's mark that. We did 2 little swoopies on the last one, so we're going to do 3 little swoopies on this angle. 1, 2, 3. 1, 2, 3. All right, now look over here on E. They told you that E is 82 degrees. Here on the triangle on the left, they had it labeled as 5y minus 3. That's not super helpful. We don't know what y is. They didn't tell us what y is. Now, you can solve for y if you wanted to say, okay, well, 5y minus 3 is the same thing as 82 degrees. You could go over here and you could set those two equal to each other and solve for y, but that's not going to get you anywhere. That's not going to get you any closer to the answer because the question that they were asking was to find the value of x, right? So don't waste your time doing that. What you can take from this information is that since those two angles are congruent, we know that angle C is 82 degrees. All right, so we know that angle C is 82 degrees, so that is helpful. All right, so now we've got almost the whole triangle labeled. All right, so we really only need one of these triangles because they're just reflections of each other. So to make this look a little more simple, I'm just going to cover some of this stuff up. All right, so I'm going to cover some of this stuff up. I'm going to erase these leftover pieces that didn't get covered up. There we go. All right, and that makes it look a lot more simple, right? All right, so now we've kind of gotten rid of all the unnecessary information. We've carried over all of the information that we knew about the sides that were congruent, the angles that were congruent. We've kind of compiled that into one triangle, and now we can just forget about that other triangle. All right, so the overall goal here is that we're trying to figure out what is the value of x. Now, we have this angle up here labeled. Let me switch to my laser pointer. We've got this angle at the top labeled 82 degrees. This one's labeled 50 degrees. And then this one at the bottom is x plus 6 degrees. All right, so now what do you know about in total? The angles of a triangle are supposed to add to what? So in a triangle, all of the angles are supposed to add to 180 degrees, right? All right, so that means that angle A plus angle B plus angle C must add to 180 degrees. All right, so let's just swap out what we know A, B, and C are. A is x plus 6, B is 50 degrees, C is 82 degrees. All right, so I'm just plugging those in. All right, so you've got all this extra stuff in here. You got the parentheses, you got the little degree symbols. Let's just drop all of that. You don't need that to solve for x. Right, we know that these are angles. All right, so let's just drop those. And now this is just a simple algebra problem. Right, so this is a basic algebra problem. You're going to add together the like terms, so 6 plus 50 plus 82. That adds to 138. All right, so we have x plus 138 equals 180. Now to get x by itself, remember that's what I'm supposed to be doing. I'm supposed to be finding the value of x. All right, so to get x by itself, I'm going to move that 138 over. How am I going to move that 138 over? I'm going to subtract it from each side. All right, so what's happening here is I'm doing minus 138, minus 138. It's going to cancel out over here. All right, and I'm left with x equals 42. 42 does not need the degree symbol. So look back over here at the look at the angle over here. So x plus 6 degrees. It already had the degree symbol in there. X is just a number. All right, so x is not the angle in total. All right, x is just a number. It's just part of this expression. So you don't need the degree symbol in your answer. Now, 42, that's not the value of the angle, is it? That's not the value of angle A, but that's not what they asked for. All right, they asked for what's the value of x. All right, so that's our answer. All right, but what if they asked you to find angle A? What if they said, what is the value of angle A? Well, then you would plug in that number, right? So you would take 42 and you would plug it in over here. And you would say, okay, well, angle A is equal to 42 plus 6 degrees. What's 42 plus 6? 48. All right, so angle A is actually 48 degrees, but the value of x is 42. All right, so make sure you're reading the question carefully. Make sure you are, you know, asking yourself, what am I supposed to be finding here? That way you're not doing more work than you need to. All right, so make sure you're reading the question carefully. Make sure you are totally clear on what they're asking for. And that way you don't, sometimes it's hard to know when to stop. So that way you're not taking it too far. All right, let's look at the next one. All right, so now we're getting into our theorems. I don't want to spend too much time on each of these because I know this video is already getting kind of long, and I know that the longer it is, the less people are going to finish watching the video. So the first theorem that we have here, very straightforward. It just says right angles congruent theorem, and this says that all right angles are congruent. That means that no matter what triangle you're talking about, no matter the orientation of the triangle, so what direction is it headed in? Is it drawn upside down? Is it drawn right side up? Is it sideways? Is it crooked? So no matter what kind of triangle or no matter what your angles or your diagram looks like, if they tell you it's a right angle, then that is 90 degrees and it's congruent to every other right angle on the planet. Okay, so very straightforward theorem here. It just says that all right angles are congruent. That means that the angles are equal. So here it says that angle 1 would be congruent to angle 2. So even though the orientation is flipped, those two angles are still congruent, as long as they are labeled as right angles. All right, next we have a really useful theorem. It's called the isosceles base angle theorem, and it says that in an isosceles triangle, the angles opposite of the congruent sides are congruent. So remember, isosceles triangles, those are going to be triangles that have at least two sides that are congruent. All right, so isosceles triangles are going to be triangles where two of the sides are congruent. Excuse me. And this theorem says that if you can figure out what angle is opposite from each of those sides, then that's going to give you two congruent angles. All right, so it says in an isosceles triangle, the angles that are opposite from the congruent sides are congruent. All right, so here you can see that it's labeled that the side AB is congruent to the side CB or BC. Now we just need to figure out what is the angle that is opposite from those sides. All right, so here's the line segment AB, and if you look directly across from that, you can see that the angle that is opposite from that side is angle C. And then if we're looking at the line segment CB, the angle that is opposite from that side is angle A. Right, so you're just looking directly opposite. So what is on the opposite side of the triangle? What angle is on the opposite side of the triangle? All right, so that's angle A. All right, so the isosceles base angle theorem tells us that if you know that these two sides are congruent, well, then you're going to get two congruent angles for free. All right, so this tells you that the measure of angle A is congruent to the measure of angle C. All right, so those two angles are congruent. Very useful theorem. All right, here we have the vertical angles theorem, and it just says that whenever two lines or line segments intersect, they form two pairs of congruent angles. All right, so whenever you have two lines or two line segments that are intersecting, kind of making an X shape, that's going to form two congruent angles. So you can see angles 1 and 3 are congruent, and then angles 2 and 4 are congruent. All right, so that can be useful whenever we're writing proofs. When you see two lines intersecting, you're going to know that that forms two pairs of congruent angles. Okay, so here is the big part of this section, the four postulates. All right, these are the four postulates that are typically used to prove that triangles are congruent, and they're called the side-side-side postulate, the side-angle-side postulate, angle-side-angle postulate, and then angle-angle-side postulate. And then you can see I have their abbreviations there as well. So side-side-side is SSS, side-angle-side is SAS, angle-side-angle is ASA, and then angle-angle-side is AAS. Okay, so if you have taken trigonometry, you may notice that there's one missing here, and that is the side-side angle postulate. And that's because that postulate does not always guarantee that two triangles are congruent. There's like an extra case where sometimes it forms a triangle that cannot exist. All right, so one of the sides is not long enough to connect with the other side. So that is why you're seeing that one postulate missing. If you haven't taken trig and you haven't used the side-side angle postulate before, then you can just totally ignore everything I just said. Now, sometimes people will get this super quickly right off the bat, and they'll be able to quickly identify, okay, this is a side-side-side problem, or this is an angle-side-angle problem, or this is an angle-angle-side problem. But sometimes people struggle with this, so I want to draw a couple pictures here and just show you some examples. I'm terrible at drawing triangles that are not right triangles, so sometimes they end up looking like right triangles. All right, so here, let's say that you get a triangle and it's labeled like this. Okay. Okay. All right, so let's say that you're looking at a triangle and this is how it's labeled. All right, so you're going to read that triangle around the edges. All right, so you're going to start, let me switch to my laser. All right, so you're going to start on one corner. Doesn't matter where you start. You can start up here, you can start down here. But you want to just read off what's labeled. So here we have angle, side, angle. All right, so this is an angle, side, angle problem. Now let me show you, let me draw a different one and see, oh, that last side went off the rails a little bit. Let me try that again. Okay, well, okay, that's good enough. All right, let me label some stuff here. Let's say, let's do angle over here, and then let's do this side. Let's do 2 tick marks there, 3 tick marks here. Okay. I'm just, the amount of tick marks that I'm doing is just random. I'm just trying to show you some, variation in the amount of tick marks that you're seeing. All right, so let's read this one around the edges. All right, so let me switch to my laser. All right, doesn't matter where you start. I'm going to start, let's say, here. Side, angle, angle. Side, angle, angle. Do I have any side, angle, angle? No. But if I read it in the opposite direction, if I did angle, angle, side, I have an angle, angle, side. So sometimes when you read it, it'll be like in the reverse order. Does that make sense? So instead of AAS, that would have been side, angle, angle. That would have been SAA, right? So sometimes if you read it backwards, just see if, maybe if I flip it around, it'll match one of these. All right, so I'm going to go through here. I'm going to show you examples. I'm going to show you pictures of each one. Let me label that was a angle, angle, side, angle, angle, side. All right, now I'm going to go through each one of these postulates. I'm going to give you, a little definition that you can write down to help you memorize, and I'm going to show pictures of each one. So if you're feeling like, oh my goodness, I have no idea what's going on, don't worry. We're going to go through each of these in depth. All right, so let's take a look at side, side, side. All right, so the side, side, side postulate, this is the easiest one to identify. This is where all three sides are going to be labeled with tick marks. All right, so it says if three sides of one triangle are congruent to three sides of another triangle, then the two triangles are congruent. So with each of these four postulates, side, 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 angle, angle, side, and angle, side, angle, you're going to be dealing with two triangles. All right, so you're going to have two pictures of triangles, and things were going to be labeled, and then you're going to have to decide, okay, is this a side, side, side? Is this an angle, side, angle? Is this angle, angle, side? So you're always going to be dealing with two triangles, and you're going to be having to figure out which postulate am I supposed to be using here. All right, side, side, side is the easiest. It is the one where all three sides are labeled. All right, so here's a picture of side, side, side. Here you can see that all three sides have tick marks labeled on it. It tells us that triangle ABC is congruent to triangle PQR. So that means that, you know, side AB is congruent to side PQ, and let's see, BC is congruent to QR, and lastly, AC is congruent to PR or RP, however you wanted to read that. All right, so side, 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 super easy to identify. It's going to be the one where all three sides are labeled. All right, next we have side, angle, side postulate. This one is also pretty easy because this is the only one where two sides are labeled. All right, so if you see two sides are marked with little tick marks, then you know that's side, angle, side. All right, it says, or it could potentially be not enough information. We'll come to that in just a minute. I'm getting ahead of myself. It says, if two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, then the triangles are congruent. All right, so this is just repeating itself. Two sides and the, oh, goodness gracious. Hold on, let me try that again. All right. Two sides and the included angle. And then here again, two sides and the included angle. So that's the important part. All right, so let's draw a picture here. Let's do a little triangle. Try to make one that's not a right triangle. It's tough. All right, two sides and the included angle. So let's say this side, this side. The included angle is going to be the angle that's between those two sides. So which angle, let's label them, A, B, C. Which one, A, B, or C, which one do you think is in between those two sides that I have labeled, that I have marked with tick marks? All right, so what angle do you think is in between these two sides? It's angle A. Yeah, so the included part, that means like between. So included, you're going to think between. So when you see the word included, when we're talking about these postulates, you want to think between. All right, so let's look at a diagram so you can see a visual representation of this postulate. All right, here's the side angle side postulate visually. You can see again that I have two sides labeled. Here I've got AC and AB with tick marks, and then RP and PQ with tick marks. And notice that on both triangles, the included side, or the side, or excuse me, the included angle, or the angle that is between the two sides that are labeled, is marked. All right, so we've got the two sides and we've got the included angle. All right, so again, if I'm reading this around, that's the approach that I take. So you can go like by the definition. You could, say, okay, I've got two sides and the included angle. You could do it that way. But if you want to just read it around, you would say side, angle, side, side, angle, side. All right, so I'm just reading around the triangle, reading what I have labeled. All right, next we've got the two that are that are easy to mix up. We've got angle, side, angle, and then next we're going to look at angle, angle, side. All right, so angle, side, angle, this is going to be where you have two angles and the included side. So remember, included means like between. All right, so we've got two angles and the included side. Whoa, goodness gracious. try that again. Two angles and the included side. So if two angles and the included side of one triangle are congruent to two angles and the included side, goodness, of the other triangle, then the two triangles are congruent. I was trying to erase just that little piece, but it wouldn't let me. All right, there we go. Two angles and the included sides. Let's draw a picture of what that's going to look like. I'm going to draw a little triangle. Okay. Two angles, so go ahead and just mark two angles. Let's do one tick mark, two little swoopies. Oh, that ended up looking like one. Okay, there we go. So there I've got two angles marked. The included side is going to be the side that's in between those two angles. All right, so let's mark this A, B, and C. All right, so tell me, which side do you think is the included side? Is it A, B? All right, so which side do you think is the included side? Is it A, B? Is it B, C? Or is it AC? It's AC, right? All right, so the included side is going to be the side that is between those two angles, so it's AC. All right, let's look at a visual representation of the angle side angle postulate. Right here we've got the angle side angle postulate visually. We've got a little diagram, and you can see that one triangle is flipped upside down. That's totally fine. It's totally fine if you have two triangles that are congruent and one of them, the orientation is different. So if it's flipped on its side or flipped totally upside down. All right, so if we're reading this around, we would say angle, side, angle, angle, side, angle. All right, so let's look at our last postulate. Angle, angle, side postulate, AAS. It says if two angles and a non-included side, two angles and a non-included side. So if included meant between, if included meant between, what do you think non-included means? So if included meant between, not included means not between. All right, so this time we've got, okay, there we go. Lost my mouse for a second there. Two angles and a non-included side. All right, so let's draw a picture of what that's going to look like. Go ahead and mark two angles. It don't matter. It does not matter where you label them. Let's do one here, one here. 1, 2, 3. Little swoopies. All right, the non-included side. All right, let's label this A, B, C. If the included side is between, this would be the included side, right? AB. So the non-included side, it can either be AC or BC. All right, so either one of those. You could do this one. All right, so that would be a non-included side. Or you could do AC. That's also a non-included side. So it's just a side that is not between A and B. All right, so either one of those would be fine. All right, let's look at a visual depiction of this postulate. All right, here we have angle, angle, side visually. If you're reading this around, now this one could be tricky to read. You could start here, you would say angle, angle, all the way around side. Or you could start with the side and say side, angle, angle. Right, then you would just say, oops, I read it backwards. That's actually angle, angle, side. Right, so if you did side, angle, angle, just recognize that that is the same thing as AAS, just in reverse order. All right, let's look at some examples. Okay, so it says, can we use the side-side-side postulate or the side-angle-side postulate to prove that the two triangles are congruent? If yes, indicate which postulate you can use. If no, write not enough information. All right, so take a look at the two triangles here. Sorry for the quality. This is obviously a screenshot from an old textbook. Look at the triangles here. I know the sides aren't labeled, but that's okay. Or the, excuse me, the angles aren't labeled. It just, they don't have any names. What do you see labeled here? Side, 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 right? That's it. That's all you have to do. So I guess the answer would be technically yes. So yes. We're indicating which postulate that we would use, which is side, side, side. All right, let's take a look at this one. This time they've got just some numbers written instead of the usual tick marks. So if you prefer the tick marks, you can go in and label those. It says, can we use, same directions, can we use the side, side, side postulate or the side angle side postulate to prove that the triangles are congruent? If yes, indicate which postulate you can use. If no, write not enough information. Okay, so I'm gonna label these. So 10 millimeters, I'm gonna mark with 2 tick marks. Right, there's 10 millimeters. And I'm gonna do 3 tick marks for 13. 1, 2, 3. 1, 2, 3. I do the little straight tick marks when I'm doing sides, and I do the little kind of swoopy tick marks when I'm marking angles. Right, and then for 110 degrees, we'll just do one little swoopy. All right, so reading this, let's look at what we have going on here. We've got two sides and this angle here. Would you call that the included angle or the non-included angle? That would be the included angle, right? So we've got two sides and the included angle. So it's going to be side, angle, side. All right, so first we'll say yes, and then side, angle, side. SAS. All right, last one of these. Can we use the side-side-side postulate or the side-angle-side postulate to prove that the two triangles are congruent? If yes, indicate which postulate you can use. If no, write not enough information. All right, so let's take a look at what we've got going on here. Here we've got two sides and an included angle. And here we've got two sides and a non-included angle. All right, so here we've got two sides and a non-included angle. Would y'all agree with that? So the included angle would have been over here, right? This would be the included angle. So this is a non-included angle. So this triangle looks like a side angle side triangle, but this one is two sides, and a non-included angle. So this one is not side angle side. So for this one, you would say, no, there's not enough information. All right, so the triangles do not appear to be congruent, and so we will just say no, and we'll say not enough information. Okay. All right, so just kind of taking this one step further, we have two triangles here that are marked, and we're supposed to figure out which postulate can we use to prove that these triangles are congruent, and then additionally, we're supposed to name the second triangle. And remember, the order is important, so we have to be careful how we're naming this triangle. We can't just randomly, you know, we can't list it, just in alphabetical order or in reverse alphabetical order or just randomly. All right, so we've got to be really intentional with how we name the triangle. All right, so name the postulate that proves each pair of triangles is congruent. That's the first thing. Then we're supposed to list the vertices. Remember, the vertices are just, the corners. The definition of a vertex is where two sides meet up. All right, so we're supposed to list the vertices of the congruent triangle in the correct corresponding order. All right, so what postulate do you think we're going to be using here? Look at your two triangles. Is it going to be side, 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 angle, angle, side, or angle, side, angle? It's going to be side, 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 right? We got three 3 sides marked. All right, so sorry, I was jumping ahead of myself. I thought I'd labeled that side, side, side first. But now that we know that this is side, 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 all right, we've already established that. This is side. Ooh, wrong one. Side, side, side. We already know that. Now we're just supposed to match up the vertices. All right, so they told us the order of the first triangle. It's written right there. X, Y, Z. All right, so let's match up, what does X match with in the triangle on the right? What does Y match with on the triangle on the right? You can see it's already labeled here. I've already marked it. That was an accident. But let's talk about why do these match. All right, so X is the angle that is in between the side with 2 tick marks and 3 tick marks. So find the side with 2 tick marks and 3 tick marks. All right, and that's going to be the angle that matches with X. All right, so X matches with H. Now for Y, Y is the angle that is in between the side with 1 tick mark and 2 tick marks. All right, so find the side with 1 tick mark and 2 tick marks. The angle between that matches with Y. All right, and that leaves Z, which is the angle that is in between the side with 1 tick mark and 3 tick marks. All right, so the angle that is between the side with 1 tick mark and 3 tick marks is G. So Z and G match up. All right, so now we can name this. X matches with H. Y matches with J. Z matches with G. All right, so H, J, G. And that is by the side, side, side postulate. Okay. Okay, let's look at another one. All right, name the postulate that proves each pair of triangles is congruent. Then list the vertices of the congruent triangle in the correct corresponding order. All right, so we got a lot of triangles here. We got 4 triangles. Now, if you look at the bottom of the screen, that's going to tell you kind of what you're working off of. So it says, okay, you've got to find the triangle that matches or that is congruent to triangle ABC. All right, so let's look at triangle ABC, and then that'll give us somewhere to start. All right, so here's triangle ABC on the far left. Let's look at what we have marked here. We've got 2 angles and a side. Now, would you say that this side is an included side or a non-included side? Do you think that that side is an included side or a non-included side? It's non-included, right? It's not in between those 2 angles. All right, the side that's in between those 2 angles, that's AB. So that's this little line segment right here. BC is not in between those 2 angles. Right, so it is not directly in between those 2 angles. So this one is going to be, for reading this around, so if it was in between, that would be angle, side, angle. Since it's not in between, that's going to be angle, angle, side. Angle, angle, side. All right, so now we've got to look at these other 3 options, and we've got to say, okay, which one of these is angle, angle, side? All right, so looking at triangle DEF here, I don't know if that's the right way to name it, but we'll just say looking at the second triangle, angle, so 2 angles and a non-included side. All right, so angle, angle, side. So we've got a contender here. Next one, the third triangle, angle, side, angle. All right, so this one is not a contender. That one is out of the running. All right, so it's supposed to be angle, angle, side. That one was angle, side, angle. All right, the last one is also not a contender. Why do you think that is? What postulate is that triangle referencing? Angle, side, angle. Again, right? All right, so triangle DEF, or we actually aren't sure how it's supposed to be labeled, but the second triangle is our winner here. It's the triangle that's congruent to triangle ABC. Now we've got to figure out how we're supposed to label it. All right, so triangle ABC, A is the angle that's labeled with 2 tick marks. So D here is the angle that's labeled with 2 tick marks. B is the angle that's labeled with 1 tick mark. E is the angle that's labeled with 1 tick mark here. So B and E match up. And then BC matches with EF. Would you agree with that? BC matches with EF. So B is the angle that's labeled, and then C is the side that's connected there. All right, so that tells us that this triangle, once we've matched all this stuff up, A matches with D, B matches with E, so C must match with F. So we're going to name this triangle DEF, and you can see I forgot the triangle symbol. Let me throw that in there. Triangle DEF, and that was by the angle side postulate. Okay, so let's look at our first proof. We're going to start by just looking at what we are given. We're going to take a look at our diagram. We're going to look at what we're trying to prove, and then we'll get into all this stuff at the bottom. So right now I just want you to focus your attention up here at the top, and we're just going to read through this information. Fill in the blanks to complete the proof. All right, so we're given some information here. You can see those three little lines of information. We're asked to prove that these two triangles are congruent. It says, given that line segment AC, and then this weird symbol, and then we have line segment DC. Do y'all remember that symbol? Do y'all remember what that symbol means? It looks like an upside down T. That symbol means is perpendicular to. Right, so is perpendicular to. Now let's talk about what does it mean to be perpendicular. If I say that two line segments are perpendicular, what does that mean? What kind of information does that give me? Right, if two line segments are perpendicular, then they intersect at a 90-degree angle. Right, so that's important. Remember, 90-degree angle, that's our right angle. Right, so, excuse me, if two line segments are perpendicular, that tells us that they are going to intersect and form a right angle. Okay? All right, so let's take a look at our proof again. All right, so again, fill in the blank to complete the proof. Line segment AC is perpendicular to line segment DC. Okay, so that tells us that, let me use my laser pointer first. All right, so line segment AC, that's that straight line in the middle, is perpendicular to line segment DC. All right, so that means where those two line segments intersect, or where they cross, they form a right angle. All right, so draw yourself a little right angle right there. All right, and then secondly, the second line says, I'm also given that line segment AC is also perpendicular to line segment AB. All right, so line segment AC, again, that's that straight one in the middle, is perpendicular to line segment AB, which is up there at the top. All right, so where those two cross or intersect, they form a right angle. So let's draw that in. There's another little right angle here. Okay. And then lastly, the last piece of information we're given says that line segment AB, that was that one at the top, is congruent to line segment DC. All right, so line segment AB is congruent to line segment DC. All right, so let's go ahead and label that. Okay. All right, so we've got a pretty good amount of information here. We've got you know, these matching angles here. These are both right angles. Remember, we had that theorem earlier that said that all right angles are congruent. That was that right angle congruent theorem. And then we've also got this congruent side. And then also notice that these two triangles, they share a side. They both have side AC as one of their sides. Right, so they've actually got two matching sides, right? Because this one in the middle, you know, is the same on both triangles. All right, so let's look at what we're trying to prove. We're trying to prove here that triangle DCA, right, so DCA is congruent to triangle BAC. Okay, DCA is congruent to BAC. Okay. All right, so we're supposed to complete the proof below, and the first line of the proof says, line segment AC is perpendicular to line segment DC, comma, line segment AC, I said congruent to, didn't I? I meant to say perpendicular to. Let me start over. Line segment AC is perpendicular to line segment DC, and then line segment AC is perpendicular to line segment AB. Okay, so how did we know that? That was given to us, right? That was part of what was given to us. So we can easily fill in that first line with given. All right, you can see that I had that preloaded in there, that those congruent tick marks were going to pop up. I originally just labeled them with one congruent tick mark. That's fine. When I did this earlier, I put two in. So either way that you labeled it, it's fine. All right, so that first statement was just given to us, that they told us that those line segments were perpendicular. That was part of what was given, so the reason is just that it was given. All right, the next line says, angle DCA, right, DCA, so that's that right angle there, and angle CAB are right angles, CAB. Yep, that's also a right angle. We've got that labeled. Now, how did we know to label that? What was the reason that we had for labeling that? That was the definition of perpendicular, right? So we talked about that the definition of perpendicular is that the two line segments cross or intersect at a 90-degree angle or a right angle, okay? So angle DCA and angle CAB are right angles. That was the definition of perpendicular. Now the third line has the blank on the statement, and the reason that they give is that right angles are congruent. Right, so we need to write down just a statement that shows which two right angles are congruent. All right, so the two right angles in question, they were given to you on the previous line. All right, so they're right here and right here. All right, so we're just going to say angle DCA is congruent to angle CAB. All right, so angle DCA is congruent to angle CAB. And the reason there is that right angles are congruent. And remember, we said earlier that that's actually a theorem. So you could also see this written as right angle congruent theorem. So the reason that they gave in this particular proof just says right angles are congruent. You could also sometimes see that reason written as right angle congruent theorem. All right, then the next line, our statement is blank again. All right, so statement is blank again, and it says the reason is the reflexive property. Do y'all remember the reflexive property? The reflexive property is like x is equal to x, or, 5 is equal to 5. Right, so whenever you see reflexive property in a proof, it's almost always going to refer to a side or an angle that is shared between two triangles. All right, so look here. We said at the beginning that line segment AC, side AC, however you want to describe it, that is shared between those two triangles. They have that in common. All right, so that's going to be what we use to, that's going to be our statement that relates to the reflexive property. It's just going to be that line segment AC is congruent to line segment AC. That's the reflexive property. It just says that, line segment AC is congruent to itself. Okay. So anytime you see reflexive property, that's almost always going to refer to a shared side or a shared angle between two triangles. Okay, so what we're doing now is we're trying to set this up so that we can use one of the postulates to prove that these two triangles are congruent. And the two triangles in question are this triangle on the left here. What did they say? DCA, they called it. And then our second triangle is BAC, is what they called it. So I'm just looking right here in the proved part. All right, so we're really just trying to set this up so that we can have, one of our postulates being used to prove that these two triangles are congruent. Now, since AC is congruent to itself, you can mark that side as congruent. All right, so you can think of that as like a congruent side. Now, Next, we're also given this little chunk of information here. It says line segment AB is congruent to line segment DC. We had already marked that earlier when we first started talking about the proof. So we had already marked that. We don't we don't need to mark anything else in our diagram. We just need to explain how we knew that. And the way that we knew that was just that it was given to us, right? So line segment AB is congruent to line segment DC. That was given to us in the beginning of the proof, right? So that line is just given to you. And then the last line says triangle DCA is congruent to triangle BAC. Now we got to figure out which postulate. All right, so for a moment, I want you to ignore, I'm actually going to use white, so maybe it'll kind of mark it out. Why is it not working? Nope, that's not working. Okay. Here's what I don't want you to look at. So don't look at this part over here. Just look at this little triangle on the left. And let's look at what's labeled. Okay. So let me switch back to my laser. We've got two sides and an angle. Is this angle included between the sides? Yes, it is. So this is two sides and an included angle. So that's side, angle, side. All right, let's double check, just verify that the other triangle is using the same postulate. Okay, there we go. This time I want you to ignore this stuff over here. We're looking at the triangle on the right. If you're doing this, you know, with your paper in front of you, you know, just use your hand to cover up the triangle on the left and the triangle on the right. Okay, so now we're looking at the triangle on the right. So we're looking over here. We've got two sides labeled and an included angle. So side, angle, side. All right, so both triangles are using the same postulate, side, angle, side. So there we go. Side, angle, side is you can put side, angle, side or side, angle, side postulate. Either way would be fine. But that is the postulate that allows us to prove that those two triangles are congruent. Okay, so basically what happened here is we started off, we looked at what we were given and we labeled the diagram accordingly, right? So we labeled everything we could. And then we went down to our proof. We went line by line and said, okay, either what was the reason that justified this statement or what is the statement that corresponds to that reason, right? So just take it line by line. If you get stuck on a line and you think like, I don't know where to go from here, just take a break. You can take a picture of the proof, email it to me, ask me a question, or you can just take a break and come back later and it might just pop right out at you. You know, it might be something that you were just, it was right there in front of your face and you were just overlooking it. All right, so sometimes you have to take a break when you're doing these. It can get, your brain can kind of get overwhelmed. All right, so taking a little break from the proof and doing a fun problem, which I think it's a fun problem. It says find the unknown angle measures. So that's going to be y and z, right? So we don't know y and z, but we do know that they're equal, right? So they're marked as congruent. So we know that they're equal. All right, so let's figure out how we're going to do this. All right, so we have x, y, and z in this triangle. We got angles x, y, and z. Now, all three of those angles have to add to what? 180, right? All right, so now let's just plug in. We already know that x is 58 degrees, so we'll start by plugging that in. You can see that I've dropped the degree symbols. You don't have to include the degree symbols in there. If you want to carry them line by line, that's fine, but I just go ahead and drop them. And then I'll put them back in at the very end. Okay, so we've plugged in 58. But there's one extra piece of information we know. What do we know about y and z? They're equal, right? These angles are marked as congruent. That means that they have the same measure. All right, so y and z, they're really the same number, right? So y is equal to z. So I'm going to take y and replace it with z. Is that okay? What do you think? Do you think that's okay that I replaced y with z? Yeah, it's fine, right? Because y is equal to z. They're the same thing. So they are interchangeable. Right, so I have replaced y with z, and that makes this super easy from here. So basically what has happened is we've went from having two variables down to one variable. Right, so now we can just combine like terms. Z plus z is 2z. All right, and then I'm just going to solve for z. So I'm going to move that 58 over. I'm going to subtract 58 from both sides. That gives me 2z equals 122. And what do you get when you divide both sides by 2 to get z by itself? What's 122 divided by 2? 61. All right, so z is 61, and so is y. They're both 61 degrees. Now you can check your answer on this just by adding those three angles up and make sure that they add to 180. All right, so you can check your answer on this one. Just make sure those three angles, that those three angles add to 180. All right, another fun proof. It says complete the two-column proof by filling in the blanks. Right, and it says that you are given that angle N is congruent to angle S. And notice that they've already got that labeled for us. Right, so they've already got it labeled that angle N is congruent to angle S. Then it also gives us that line L, which is that vertical line in the middle, bisects the line segment TR at Q. All right. Line L bisects, remember that means splits it in half. So that means that line L splits TR in half. Right, now that's important because that tells us that TQ or QT, line segment QT, is congruent to line segment QR. Right, so that got split in half. So imagine that this total length is like 40. Then that's 20 and 20. Right, so it splits it in half. So now we know that those two little chunks are equal. They're congruent. Right, so we can mark those as congruent. Now we've also got an extra piece of information here that's just kind of given to us for free. And this is by the vertical angles theorem. Do y'all remember that? It said that if you have two lines intersecting, which is like NS and RT, so those two lines that I'm tracing there, if those two lines intersect, they form two pairs of vertical angles. Do you remember that? That was the vertical angles theorem. Now this one we don't really care about. That's not inside of our triangles, so that vertical angle there on the top and the bottom is kind of irrelevant. But it does form this little congruent pair here. And we kind of get that for free because we know that vertical angle theorem. Right, so we're just going to keep that in the back of our mind. We may have to use that later. And we're supposed to be proving that triangle NQT is congruent to triangle SQR. All right, I just realized this kind of looks like a butterfly, don't it? Y'all see that? Like a little butterfly. All right, so we're trying to prove that those two triangles are congruent. Remember the sort of tools that we have in our tool belt for proving that triangles are congruent. That's those four postulates. So anytime you're asked to prove that two triangles are congruent, you should know right off the bat, okay, I'm going to be using one of my postulates, either side, 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 angle, or angle, angle, side. All right, so if you see that you're supposed to be proving that triangles are congruent, know that you're going to have to use one of those four postulates. All right, so let's look at our proof. The first line says the statement is, angle N is congruent to angle S. That was given to us, and they already had that filled in. So next line says angle NQT is congruent to angle SQR. We just noted that, didn't we? We just wrote those little tick marks. And what was the reason that we wrote those little tick marks? What theorem was that? That was the vertical angles theorem. Remember, so if we have two lines that intersect, they form two pairs of congruent angles. And we said these that are on the outside of these triangles, they're really irrelevant. We don't really care about those, but we do care about these angles, these pair of congruent angles that are inside the triangle. So the vertical angles theorem allowed us to mark that as congruent. And then the third line says line L bisects the line segment TR at Q. That was given to us, right? So that was part of what was given. Let me erase my extra little tick marks there. There we go. All right, so that was given to us. All right, so on line 3, line L bisects line segment TR at Q. That was part of what was given. All right, then line 4, it says we are missing the statement. Sorry, I keep losing my mouse for some reason. Y'all see it's acting crazy. Well, let me. Okay, there we go. Turned it off and turned it back on. Okay, so the statement is missing. The reason says definition of bisector. Do y'all remember when I told you about the bisector? What did we mark? Do y'all remember? That's where we mark those congruent sides. Because we said that a bisector is going to split that line segment TR in half. All right, so this is saying by the definition of the bisector, those two pieces are congruent. All right, so that's going to be our statement. All right, so let's figure out what we're going to write. Line segment QT or TR is congruent to line segment RQ or QR. Okay. All right, so TQ is congruent to QR. Line segment TQ is congruent to line segment QR. And that was by the definition of a bisector. All right, so a bisector splits things in half. Excuse me. All right, and then our last line, triangle NQT is congruent to triangle SQR. All right, so now you just got to figure out which postulate are we supposed to be using here. So we've got, I'm just looking at this triangle on the left, so like the left wing of the butterfly. All right, so I'm looking at this left side. I see that I've got two angles marked and a side. Now, is this the included side or is it the non-included side? That's the non-included side, right? So the included side would have been over here. This is the non-included side. All right, so if you're looking at your definitions of each one of those postulates that you wrote down earlier, the one with the non-included side, that was angle, angle, side. Angle, angle, side. So the angle, angle, side postulate guarantees that those two triangles are congruent. All right. We got another kind of easy problem, one with numbers instead of proofs. It says complete parts A and B using the figure below, given that the measure of angle C is 67 degrees. Now, I don't love this problem, and you definitely aren't going to see it on the test, but I threw it in here just as an extra example, just to kind of, I'm just trying to give us some variation in our problems here. So doing a proof and then kind of taking, a minute to let our brain rest. And doing a problem with numbers. So this is not my favorite problem, but we are going to use it just sort of, to come down from that more difficult problem that we just did. All right, so the reason that I don't like this problem is because I believe that they should have marked this as a right angle. So if I was to give this to you, I would go ahead and mark this as a right angle here, and of course a right angle here. Now I think that they are expecting you to know that because this is a straight line. So that's 180 degrees, and this is a bisector. You can see it splitting that angle in half. Sorry, you couldn't see where I was pointing. So this is a bisector. This line AD is a bisector because it is splitting this big angle into two equal chunks. All right, so that's going to form two equal chunks down here as well, so two 90-degree angles. All right, so I don't, love this problem, and I feel like they should have marked those as 90-degree angles, but we're going to use this just for practice purposes. It says find the measure of angle 2. Well, angle 2 is a right angle, so it's 90 degrees. All right, and then lastly, find the measure of angle CAB. All right, CAB. All right, CAB. So they told us in the beginning that angle C is 67 degrees, and we just found out that this is a 90-degree angle. All right, so if we know that angle C is 67 degrees and angle 2 is a 90-degree angle, we know that in this little triangle here on the top, I'm just looking at the top here, you can kind of, let me mark this out. You can ignore all the stuff that's happening down here for just a moment. We'll come back to it. All right, so just ignore all that. All right, so just focusing on this triangle at the top. We know that C is 67. We know that angle 2 is 90 degrees. So all three angles have to add to 180. All right, so let's add those together. 67 plus 90 is 157. I'm going to subtract 157 from both sides to get that angle CAD by itself. So CAD is that little angle there on the right. So subtracting 157 from both sides gives me 23 degrees. 23 degrees. All right, so we know that this angle is 23 degrees. Well, that angle is marked as congruent to this angle at the bottom. So that one must also be 23 degrees. All right, so this angle at the bottom is also 23 degrees. Let me write that on there. So if we're looking for the measure of angle CAB, that's what they asked us in the problem, CAB. You can see I've got it highlighted there. That's made up of those two little chunks, 23 degrees, 23 degrees. So you're just going to add those together. 23 plus 23 is what? 46. All right, so angle CAB is equal to 46 degrees. Okay, so what do I want you to take away from this section? I want you to make sure that you are comfortable with identifying what postulate that you're using. So make sure that you draw some pictures or print out the notes and cut some of those pictures out, paste them to a index card and flip through them every day. Make sure that you are comfortable identifying which postulate that you're referring to or that's being used when you're proving that two triangles are congruent. I also want you to remember a couple of other theorems that we had, which was like the right angles congruent theorem, the vertical angle theorem, and then the isosceles base angle theorem. So make sure that you get those down as well. I know this was a long video, so if you stay till the end, you are a real one, and I really appreciate you. I'll catch you guys in the next video, and please let me know if you have any questions or if you need any help.